Greetings, M squared here. Today we are going to talk about learning target 5, which is comparing the properties of linear, exponential, and quadratic functions in 3 different forms: equations, tables, and graphs. So you're going to have to look at a graph, a table, or an equation and determine whether it's a linear function, an exponential function, or a quadratic function. So let's remind ourselves of these 3 things. We've learned them this year, so this should all just be review, but we're going to remind ourselves that a linear equation is a line. We can tell because the first 4 letters spell the word line. And a line always has a y and an x. They don't have exponents on them, absolute values, square roots. They're just plain old x and a plain old y. They might be multiplied. You might have something multiplied by y or x, but it's a number. It's not another variable. And then this is also a number. So that is in slope-intercept form, but we learned different forms, right? We learned ax plus by equals c. So you could have y equals 3x minus 7. You could have 2x plus 3y equals 6. All sorts of ways to write an equation of a line. You need to be able to look at all the equations I give you and determine which ones are linear. And you're going to do that by just noticing plain old x and y. Here you have an x and a y as well, because anything on a coordinate plane is going to have an x and a y. This is the x-axis and the y-axis. That's how it rolls. But notice that in an exponential equation, the x is the exponent. That is how you can tell if an equation is exponential. The x is the exponent. And that is what you need to remember for that one. And it's a curve. It's kind of slow to go up, and then it goes up a little faster and faster and faster. Exponential. Last, we just got finished talking about quadratic functions. How can you tell an equation is a quadratic function? So glad you asked. It's because the x has a squared. The highest degree is 2. We have an x squared. You may or may not have an x. You may or may not have a constant. You will always have an x squared when you have a quadratic function, and we call that shape a parabola. All right. That is how you tell for an equation. That is how you tell the graph. Let's look at tables, because I think this is probably the most tricky. Not if you remember the rules, but if you don't, it can be the trickiest. So we want to check what's happening each time. Whatever table we look at, that's the first thing you want to do. Now, I'm not going to trick you, but if you were in another class or doing this on another area of science or math, you'd want to make sure that these were, one right after the other, consecutive integers. If they're not, it could be tricky. You might not see the pattern correctly, but they are, and I'm not tricking you. So we're just going to talk about the y's for now. What's happening? What do I do to 9 to get 5? What do I do to 5 to get 1? Well, let's look. That's subtract 4, subtract 4. So I notice that each time I'm subtracting 4 from the previous y to get the current y. And when I add or subtract the same number each time, that is a linear function. That's how I can tell it's linear. You'll notice over here, I'm multiplying by 4 each time. Each time, times 4, times 4, times 4, times 4. All right, when I multiply or divide this y to get to the next y, that means it's an exponential function. That is how I can look at a table and tell if it's exponential. And finally, for the quadratic, it's the second difference that's the same. Let me show you what that means. To go from 5 to 2, what would I have to do? I'd have to subtract 3. To go from 2 to 1, I would have to subtract 1. And then do you see it's coming up again? It was going down, now it's going up. Now that's a plus 1, and now that's a plus 3. Well, hopefully you see the 1, 3, it could be 1, 3, 5 pattern going on. Remember that we talked about? But watch what happens if I take the second difference. That means I take the difference between these numbers, the first difference numbers. That is minus 2 plus 2, plus 2, plus 2. Got my minuses mixed up. So do you see that the second difference is 2, 2, 2, 2, 2? So when the second difference is the same, that's quadratic. And what's cool is when you learn about cubic and quartic and on, you take the third difference would be the same for cubic, the fourth difference would be the same for quartic. It's kind of cool that way. All right, you ready to practice? Let's practice. So here we are going to figure out if it's linear, exponential, or quadratic, or neither. So this would be a good time to pause the video, decide for yourself what those equations are, and then come back because I'm going to explain it. So right here, remember f of x is just another way to write y. It's just telling us it's a function, and all these things that we're talking about are functions. And this is a plain old y and a plain old x, so we know that's linear. This has a squared, an x squared if we multiplied that out, so I know that's quadratic. That's how I can tell it's quadratic. That's what I'm looking for. This also has an x squared, so I'm going to call that quadratic. This has an x as an exponent. It's going to be exponential. I'm just putting the L, Q, and E. That's what the directions say. You can write out the word if you want. This one has an x squared, so I'm thinking, oh, it's quadratic, but then I look right here and it's got an x cubed. That makes it cubic. Well, those aren't one of the three that I've learned, so I'm going to say neither. Okay, it's just not that one. Oh, it says put an n in the box if it's not linear, exponential. Oh, an n for neither, if it's not any of those. All right, you wouldn't think I made those directions the way I'm reading them. Here we got an x and a y. Nothing fancy going on. The x isn't an exponent. There's no squared. It's linear. Exponent of 2. That one is linear, so I'm good. We've got a quadratic. And here we've got an x as an exponent. We've got exponential. How'd you do? I hope you did great. Now we're moving on to the graph. So this would be a good time to pause and just see if you can tell the difference. Let's go. Here we go. It's a curve. It's not a line, so that's not linear. It's not a parabola. That's an exponential curve. This one right here is interesting. This part looks like a parabola, but then it stops and kind of curves that way. Well, that's not any of the three that I've learned, so we're going to say neither on that one. That's actually a sine, a cosine curve, depending on the shift and everything. You'll learn about that in geometry, algebra 2. You'll learn about that later. But all we need to know is it's not linear, it's not exponential, and it's not quadratic. This is a line. A line is linear. Those are pretty easy. This is a parabola. It's upside down, but it's still a parabola, so we know that's quadratic. Another parabola, we know that's quadratic. And then this one is actually a cubic function, which you haven't learned yet, but we can tell it kind of looks like a parabola there, but then it looks like another parabola here. That's a cubic function. And so we're going to say neither on that one. All right, next is the tables. Another good time to press pause and see if you can figure out what's happening. We're going to look here. Remember, we're going to remember that if we add the same thing or subtract the same thing, it's linear. If we multiply or divide the same thing, it's to find the next y, it's exponential. And if the second difference is the same, or we recognize that quadratic pattern, then we are going to know it's quadratic. So this is -4, -2, -2. Actually, that was 0, wasn't it? Sorry. Let's see, what is this? +2 and then +4. So let's see what our second difference is, because it's not added every time, right? We didn't have the same thing added. We didn't have the same thing multiplied. The second difference is up 2 each time. That means it's quadratic. So even though you might not have noticed a pattern there, we're going to say that that's quadratic. Whoops. Oh yeah, quadratic. And you don't actually see the vertex in this one. I wanted to show you that. These are the same and then these are the same. So the vertex would be right here. The vertex, so the table might look a little different than the patterns we were used to. So I want to make sure you understand that the vertex is sitting in there probably at 1/2 because these two are the same. But because the second difference was the same, it didn't matter if I didn't see the vertex. I can see that it's quadratic because that second difference is the same. All right, let's see what's happening. Again, if you don't like negative numbers, you could always come down here and ask yourself what's happening. Let's see, 4, 11, 18. I know that 18 minus 11, right, that's 7. So I'm adding 7 is 7 plus 4. That's 11. So, right, 7 plus 4 is 11. And so I just kind of check. Yep, there's 7 between there. Yep, 7. Yep, 7. All right, well, this is adding 7 each y to get to the next y. That makes it linear. Next, let's see what's happening. If you don't like decimals, then come down here. What's happening? Times 4, times 4, times 4. Well, is 0.25 times 4? Yeah, that's 1/4 times 4, 1. Yep, it is 1. I think that's 16th. 1/16 times 4 is 1/4. So we can see that it's being multiplied each time. That means that would be exponential. I hope that you remember all of those fun little things, because when you do it, you are going to need to be able to do that. You need to know the adding, subtracting is linear. The multiplying and dividing is the exponential, and the second difference being the same is the quadratic. So you're going to have to memorize those things. Practice will help you with that. Good luck. M squared signing out.